Okay, good. Okay, yes, so actually, technically we are sort of, I2CAM is sort of the Chevy to ICAM General Motors. I'm not sure I should use that metaphor these days, but I2CAM is a part of ICAM, the Institute for Complex Adaptive Matter, which is funded by the NSF, and we're funding this partly from ICAM funds and from I2CAM funds. What we're interested in is emergence, and emergent phenomena we consider to be phenomena that owe their existence to interactions between many subunits, but whose existence cannot be deduced from a detailed knowledge of those subunits alone. Or to put it another way, how can a collection of molecules think about what molecules are? Obviously, maybe the holy grail for emergence is understanding consciousness. We're not doing that in ICAM, at least not yet, but maybe in the future. We consider complex adaptive matter to be materials exhibiting emergence, and examples would be novel superconductivity and things like the new iron pnictide materials or the older cuprate and heavy fermion materials, which are still poorly understood, amyloid assemblies of proteins, liquid crystals, like in the meeting here. And the central ICAM mission is to basically search for organizing principles of emergence in complex adaptive matter. The belief is, from those of us who helped to found this institute, is that this really has to be experimentally driven, and I think that's on evidence at this meeting dramatically, that you have to find new phenomena experimentally and then try to find the appropriate description at the length scale and time scale relevant to that particular phenomenon. We are a growing organization. We now have 57 ICAM branches worldwide, including the University of Colorado Boulder, UC Davis, a number of branches in the US. This is just giving you an idea of the time dynamics of that. So we started with 9 founding branches in 2002, and now we've kept adding every year. We've subtracted 3 along the way, but this gets us up to 57 branches at present. And the idea of the network, the ICAM network, is basically to exchange between these branches using the mechanisms of workshops, exchange awards of junior scientists, and travel awards of junior scientists, as well as some postdoctoral fellowships and some senior fellowships for people who might be interested in going on sabbatical, for example. Always the exchange awards and the fellowship awards have to involve travel between ICAM branches, basically. Okay, and just to give you an idea of where we get our money from, our international award is the biggest single award. That's an International Materials Institute award from the NSF. It's entering its 5th year now. We're up for renewal. We get $700,000 a year right now, and we've requested an increase to $1.2 million if we're successful with renewal. We get contributions from each of our branches. When you're a branch, you commit to keeping a certain amount of money at home and also contributing some money to the overall ICAM pool to fund ICAM activities. We have a smaller domestic award, which we're putting up for renewal on the same time frame, and a support from foundations, which is all for outreach activities, which I'll tell you a little bit more about. And so these are the main ICAM and I2CAM activities, and I'm sorry I forgot to list the fellowships on there, but we also have postdoctoral fellowships and senior fellowships separate from these. So we have exchange awards for junior scientists to carry out 2 to 12 months of research, travel awards for junior scientists for meetings or short research trips, exploratory workshops, 10 to 12 per year. We can decide those quickly on a quarterly basis from our science steering committee. Schools, we have a continuing school at Carjaz, one that we've started at Rio de Janeiro, which we've had 2 of so far. We're planning to have a school in Bangalore as part of our new proposal. If the proposal is successful also, there will be a school that rotates between Boulder and the Ukraine or Eastern Europe on photonics of complex adaptive materials. We have outreach activities, I'll tell you more about that, and we have a website which Jason Wiskershin's company has set up for us, which hosts all details of our community. Our main science thrusts are in the areas of correlated electron matter, which would include things like these iron pnictide superconductors, the so-called heavy electron materials, the cobaltates. We had the first international workshop on the cobaltates, and we'll have one of the first US workshops on these iron pnictide superconductors coming up in the fall. Biological matter, including things like proteins, protein aggregation, the first international interdisciplinary workshop on the glycome, the sort of spectrum of sugars in biological matter. And then soft matter, such as liquid crystals, colloidal matter, and granular matter. We're very happy to add this direction to ICAM just in the last year or so. We've had a lot of publications. I know very well the I2CAM ones because I just had to write the renewal. 49 I2CAM publications, including 3 in Nature, 3 in PNAS, and 1 in Science. 1 with a lead movie in online journal Optics Express that Iwan is responsible for. And those have been cited several hundred times so far, but well over 100 publications for ICAM over the years. This is an example of one of our best triumphs. This was done by an exchange award scholar, Kazuguro Fujita. I'm violating the rules of presentation here slightly because this actually was sort of a nugget sent to the NSF, so this is a little bit too dense in prose. I apologize for that, so it's violating those presentation rules you heard about yesterday. But this sort of tells the story. This is Kazuguro Fujita made the samples in Tokyo, carried them to Cornell to work in Seamus Davis's STM lab. And what they are is they're samples of the high temperature bismuth, calcium, strontium, copper oxide superconductor. And this is a particular way of imaging it. So you see the topographic image down below with a few defects of the surface of this material. And these yellow lines are emphasizing some electronic fades of these materials which had not been discovered before. It looks pretty ordered, but if you look in detail, you'll see that it's not, that there are little patches of bond ordering in here on the nanometer scale. So in fact, this is believed to be an intrinsically disordered electronic phase, and it doesn't, there's not a good correlation between the particular order in this phase with the underlying topographic order. Those are the main points from the experimental studies, and this is definitely an emergent result. And independently, some theorists, Peter Walness and Georg Schmalian, proposed an idea that may or may not describe this, but it connects to the soft matter you're hearing about in this workshop. They came up with the idea of electronic mayonnaise. Now, you probably know that mayonnaise itself is a microemulsion with structure on the micron scale, in which you get oil and vinegar to mix by putting it in an emulsifier, which is coming from the egg whites. And so that will give you interesting structure on the macro scale, which you see here, and on the micro scale, which you see down here. The proposal of Georg and Peter is that in the case of these copper oxide superconductors, when you dope them away from the antiferromagnetic insulating phase, that you can get these antiferromagnetic regions which are electron rich. You can get these white charged regions which are rich in the doped holes. And that the emulsifier is basically the Coulomb interaction between those slightly charged contrasted regions. And then they can get actually, from their theory, they can get a mayonnaise-like structure on the nanoscale. Intrinsically, without putting in underlying disorder, which is the interesting point. Another thing, and I won't go into detail here, but with the travel award, we supported a student from Davis, Avinash Kane, to go to the synchrotron in Hamburg. And he was able to construct a nice rig in which you could do time-resolved studies of fast protein, or not so fast actually, but you could do time-resolved studies of protein folding kinetics on the synchrotron. And this, with a modest investment, some very nice work has emerged from this. There's too much, again, a little bit too much detail, but I'm just giving you the upshot that one travel award for about $1,500 was able to facilitate these experiments at Hamburg. Let's see. This is just to give you an idea of one of the other aspects, workshops. We've now held, let me think, 26, I think, I2CAM workshops all over the world, and oh my goodness, dozens of ICAM workshops overall. This was from an I2CAM workshop in 2005 on Hvar, which is a beautiful island off of Croatia. And this was on correlated electron materials used for thermoelectric applications. And then we have schools, for example, Cargés. If you haven't been to Cargés, I haven't been yet actually, but I'm told it's very beautiful. The school is very close to the coastline of Corsica, and this was one we held 2 years ago on the physics of cellular objects. Going on right as we speak is a school on soft condensed matter at Cargés. Let's see. This is to give you some idea of where all of our exchange awards have gone. Oops, let me back that up. Where all of our exchange awards have gone over the years. I'm sorry. Here we go. To give you an idea that we are networking worldwide with these exchange awards, going all over the world. The common link on the International Exchange Awards is that always they have to either come to the US or go from the US to abroad. And there are simple rules for the exchange awards, simple organizing principles. They provide reasonable per diem and travel expenses for 2 to 12 months for graduate students or postdoctoral researchers, or good undergraduates too, I should say. We've had a couple of those. They just require a little bit of proposal, CV with publication lists and letters of support. They can also be initiated by mentors as well. And as I mentioned, they go from the US to abroad or abroad ICAM branches to the US. And then we also have these travel awards, and again, I have sort of a hybrid animation here. This is supposed to give the idea, there's a temporal order to these, but then they pile up pretty quickly. And again, these travel awards have gone all over the world. The travel awards are smaller, they're for shorter visits. They could be for presenting at a conference or for doing a short research visit. Those are restricted again to students or postdocs. They just require a brief description of the proposal with a support letter, and we can provide $2,500. And these are mostly for ICAM-based junior scientists, but we can support 5 to 10% of non-ICAM-based junior scientists on these, as with the exchange awards. And then also we have outreach activities. I'll just briefly show you a little bit of outreach activities, and then I'll leave some time for any questions that might be there, or lunch, whichever. One thing is we have something called the Emergent Universe, which is an online museum of emergence and matter. We're developing that, but I'll just show you the portal for that museum, because it's pretty cool. And actually there's sound. We'll try to turn up the sound. It'd be best, of course, to hear the sound on your own laptop. But okay, I think I need to click here or something. There we go. So this is aimed at the millennial generation in particular, so people from sort of 15 to 30 or so, which is not a typical place where outreach activities are aimed. And the design that Susan Tucker, a former PhD or former professor here at Chemistry at Davis, Susan designed this basically by soliciting input on what the millennial generation likes to look at online. And at present, we're going to have sort of an entry exhibit hall on unlocking the emergent universe, which will explain the phenomenon of emergence through some games, music, anime, cartoons about what emergence properties are. There will be a wing on amyloid matter, which will actually have a sort of Google map zoom in on the brain, so you can go from the upper levels of the brain down to where amyloids might actually be destroying neurons. Something about amyloids for good rather than evil, like in spider silk. Amyloids, if you don't know them, are the aggregates of proteins involved in mad cow disease and Alzheimer's, for example. And then some other issues about amyloids that would appeal to younger people. And there's some other things. There'll be a wing on quantum emergence. And then you can click, and little things will pop up, will emerge as you click. This is birds flocking. Let's see, for example, tornadoes turning. Okay, so that you get the idea. This will be an online science museum, which is much cheaper than actually building one like the Exploratorium. And we're excited about it. It looks really cool. And it's exciting in conveying the science, not just does it look cool. Also, I want to mention a few of the other outreach activities. Let's see, this is some, let me back up for a second. We have SuperNet, which is somewhat like what we heard about yesterday with the liquid crystals. It's an effort to develop modules for teachers to take home to their high school classrooms on things like magnetism, superconductivity, high field studies, and there's a wiki where the teachers can come back and put in interactive commentary about what works and what doesn't work. And this is largely emerging from our colleagues at the Magnet Lab in Tallahassee. There's these great explanations, which are short videos of ICAM scientists explaining their work. Appropriate to this session, here's Kai-Yi Lee coming up here in a second. Well, you can look at Kai-Yi Lee explaining the membrane biophysics, but apparently it's a little slow loading here, so I'll stop there. Oops, did I just lose that? Oh shoot, I just lost that. Okay, but the other sites, we have I'll just go back to the PowerPoint, just mention them. We have a condensed matter journal club run by Chandra Varma at UC Riverside, which is basically a science blog where leading condensed matter scientists comment on current papers. Piers Coleman from Rutgers developed a site called The Music of the Quantum, where he has interviews with scientists on quantum emergence and commissioned music from his brother, Jazz Coleman, if you've heard of the band Killing Joke. Jazz was the frontman for that band. But it's classical music on quantum criticality that Piers commissioned. And ICAMopedia, an online encyclopedia of emergence and matter. That gives you an overview of what we're up to. And if you want more information, you can go to our website, and you can also email me.
Are there questions?
I think, yeah, this one.
I'm just still not clear on the relationship between ICAM and I2CAM.
Right. ICAM is overall a large organization that started informally 10 years ago and formally 7 or 6 years ago. I2CAM refers specifically to the International Materials Institute grant that we got from the NSF. But they're all interlinked. And so there's a little bit more funding overall in ICAM than well, about twice the funding overall than I2CAM.
Okay, so then, one question.
So, collaboration award is between two ICAM branches only, or?
It depends. If it's from abroad to the U.S., it's between two ICAM branches. If it's from the U.S., you can actually go anywhere abroad. And it's not restricted to U.S. Citizens or anything. Yeah?
This is more for the group. Is there a liquid crystal forum or journal club established yet?
Not yet.
It'll be easy to set one up. We'd like to, in principle, the condensed matter one actually is including some soft matter and biological physics, but it's mostly correlated electron matter, so we'd like to spin off other journal clubs from it. We just need mediators for those journal clubs.
Yeah, thank you so much. And if you have some questions, you can ask them informally during the break. So we, students and postdocs, we will meet here in about 10 minutes. And everybody is welcome to pick up their lunch boxes in the room across the hall, G1B31.
Were you asking about the journal club?